I think the time is officially 20 minutes before 5. Great to see so many people, and you all look surprisingly awake still. Good job. I guess there's a party soon, so I'll try to not be too much in the way of that. My name is Egil Hansen, and I'll tell you about testing.NET Web APIs from A to C. I'll let you be the judge of whether or not we get to C or not. And actually, I want to focus on JSON-based APIs because I think that's what most people are using. But even so, most of the ideas we're going to talk about today will also apply to if you're still using SOAP or maybe gRPC. So sort of the theory behind it should still be the same. Now, well, actually, let me just introduce myself properly. So I'm a Dane living in Iceland. I work for a company called Delegate in Denmark, and I'm a Microsoft MVP for a couple of years. And I became that because I built some open source libraries, some testing libraries around Blazor, and something to do semantic comparison of HTML. So testing is sort of a thing I'm sort of engaged with. Anyway, let's get to the talk. So by the end of the talk, I hope you have a good understanding of what is actually valuable to test about an API, and also obviously how we should go about doing that. And sort of I want to underscore the word valuable here, because I think it's important that when we add new code to our code bases, so code is a liability, right? We don't want too much code in there unless it adds value. So the point is really to add tests and create tests that are valuable, that adds value to our solutions. So we don't just have wasted effort, right? We don't want just test there just to make our CI gods happy and have coverage or whatever. So we want to be intentional, we want to be deliberate about the tests that we add to our solutions. So let's start with the first point. So what does it mean to have, or rather, what is valuable to test about an API, looking at it from the outside in? And that question could be followed up by a few other questions. It could be, for example, well, who is the consumer? Or do we know the consumers? So on one side, you might be looking at building maybe a backend for a front end. Maybe you have an API that just is serving some front end. Maybe it's just inside your individual team, and you're both building the front and the back end. Maybe it's sort of all exist in the same repository, same solution. Maybe there's even some build steps that are sort of tying those two tightly together. So in that case, in that scenario, the API is more or less an implementation detail to the front end, and you probably want to test that API, not directly, but through the front end, just because you're testing the front end, perhaps using something like Playwright or something else, if it's a web API, for example. So you get that testing done through that. On the opposite side of the spectrum, we have APIs that you put out to the world. Users come in, they sign up themselves, they start using the API. You don't know the users, they might come and go. And you have maybe some documentation, you have an open API spec, you have some explicit contract you've shared with them, a promise you've given them, right? And hopefully the users are paying, right? That's kind of users we want. So you don't want to cause breaking changes. You don't want to ruin their day by changing something in your API. And then obviously your boss will come and ask you, why are my customers calling and are angry at me? So that is sort of the other side of the spectrum, where you have a lot of promises given to a lot of people you don't really know, right? So there we really have to be protective about what changes we make, and when we make changes, we actually understand that we're doing it and it's on purpose. So what is valuable to test in this scenario where the API is the product, right? So we think about that for a quick second here. And if we look at it from sort of the outside, well, it's really the externally observable behavior that the users of our API see, what they're expecting. But what does that actually mean? Well, it's the implicit and explicit date API contract. So explicit might be an open API specification you put out there, or it might be documentation. It could also be implicit things that doesn't necessarily get represented in an open API specification, for example, but something that just happens when people are using your API. So all of those things we need to sort of have an answer for. We have to have tests that cover those. So what is that explicitly? So for example, in a JSON scenario, if we add or remove a property from an object, right, that would be a breaking change to a user. It could also be that we are changing the data types of those properties to something else. We could also introduce stricter validation rules. So all of these are sort of very data-centric things. Another thing could be that we have some defaults, that if you send some data to us, if you don't fill out these fields, we're going to put some data in there. Well, if we change what that defaults are, we're going to surprise the users. Maybe we break them, maybe we don't. It could also be defaults of sorting and paging. So users might actually sort of take a dependency that data gets back sorted to them in a specific order. So again, those are things we want to look for. And sort of changing format of strict string data types in JSON. So we have a certain number of data types that it's not like number or Boolean or nulls. One example is the datetime type in JSON, and that's just represented as a string. So there are specific notations you have to follow for that, and that might be other things as well you have to be aware of. Now, if we look at the protocol level kind of thing, well, if you change the status codes and error codes, you can change HTTP verbs, methods you're using for your APIs. You could add and remove headers or change what they mean. That would also be a problem if the users are sort of leveraging those. Authentication methods, obviously, that is something probably going to be quite visible quite fast, but still. And things like change rate limitations, that might also be something that will affect the end users and give them sort of something broke, and it's probably somebody else's fault than mine. Now, what about domain business logic? Should you also be focusing on that when you're testing your API? And I think this is sort of a kind of a dependency scenario. So if you have a simple application, you have some data and you have an API on top of that, and there's not a lot of going on. We're just moving data out to the web, right? Well, typically there's not a lot of business logic in there, so then it's probably not a big problem to just test that business logic, that little business logic that might be there from the API directly when you're writing those API tests. If you have a more complex setup where you have lots of complex business rules, business environments, you might be better served sort of leveraging or leaning into a scenario where you just focus on the API parts of it in the API tests, and then have unit tests or other lower level tests that focus on the business rules. So that means also leaning into architecture decisions like ports and adapters, clean architecture, those kind of patterns, what's called functional core, imperatives of shell, those kind of things. So that enables you to test the API, focus on that at one level, and then test the data or the business logic in isolation from the data. So I can look at it from this perspective, like the classic test pyramid. And obviously, it's nice if you can have everything covered by end-to-end tests. That's going to give you good value. But you could also just say, well, we're going to focus on the API contract on top and just have the implicit business. Well, we're going to touch some business logic while we do that, but it's not going to be the focus of our test. And then you have business behavior further down. So it's sort of a question of a value versus effort spent. And we want to have valuable tests, right? Getting back to that point. So if we are on one side of the spectrum here with end-to-end testing, so there's a few properties that are really important for us when we're writing our tests and we want to have good value out of the test. It's protection against regression, which basically means that it protects us from, if we make a change inadvertently that we didn't intend to and we have a breaking change. Well, on this side of the spectrum here, if on end-to-end testing, typically, or integration testing, we have a lot more stuff going on. Typically, when you write those kind of tests, you touch a lot more things in your code, maybe all the way back to the backend databases, external process things, dependencies you have. So all of that is involved typically in tests that are there. But the downside of those tests is that they tend to run slower, right? They don't have the same speed because there's lots more things involved. And again, maintainability-wise, they tend to also be harder to maintain because there's more stuff involved. A unit test where you're just targeting a specific little type in your system, that's easy to maintain, easy to test around, versus on the other side where you have a whole bunch of things going on involved in actually sort of test it up to actually get the test running. So I'll leave it up to the reader, or to you, the listeners, to decide whether or not you want to include all the business logic in your API test. It really depends on the type of solution you're looking at and what would add the most value to you in your particular scenario. Now, so that is sort of a preamble of what we want to focus on. So let's talk about how do we actually create valuable tests. And so we have that protection against regression we mentioned before. We have the fast feedback, we have maintainability, but there's a fourth point rather, that is resistant to refactoring, which is sort of a universal, I think, in all good test suites. If you have these four properties in your tests, then you tend to have tests that are easy to maintain, easy to work with, a test that adds value to you over time. And especially I think the resistance to refactoring is important because if you go and change something in your production code and your tests start breaking left and right. I think most people have tried that at some point, right? You change something, it's an implementation detail, it shouldn't bother any of the tests. Maybe you optimize something, made things run a bit faster, but all of a sudden you have test breaking. That's typical because the test suite isn't designed to be resistant to refactoring. And you really want that because that's, if you have to go and fix your test every time you make an insignificant change to the production or to production code, or rather an implementation detail change into production code, then you have tests that detracts from the value of the test, right? That means the tests have less value to you. So that's really the sort of the 4 pillars. Now there's a whole talk in and of itself on sort of the topic of these 4 pillars. And instead of giving that, I'll point you to this book. It's an excellent book recently published by Vladimir Kornikov, and he talks about this in detail. So highly recommend reading that. Now, so I want to go and talk a bit more about the toolbox that we will be using, that I like to use when I do API testing, sort of that will enable us to get all those qualities we talked about before. And the first thing is a tool called Alba, which is sort of a wrapper on top of the web application factory. So how many of you are familiar with web application factory already? Okay, so only a few of you. So Web Application Factory is a tool from Microsoft that allows us to spin up a web API or an API we are testing in memory in the same process that our test is running. So it runs in isolation from all the other whatever things you might have running on your PC, and you can just talk to that API in isolation with that test. And it allows us to go in and override configuration and sort of modify the web API in a way that allows us to test it. Sometimes you need to turn certain things off. Maybe you need to cut off external dependencies. So that's one of the libraries we're going to use. Another library that is super useful in this case, in this scenario, is Verify. Verify is an excellent snapshot testing library built by a fellow called Simon Krupp. And because we're working sort of with raw string-based data with JSON, snapshot testing is a super useful thing to lean into, because sometimes you get a huge load of data that you want to sort of say something about, and it's going to be filled up a normal C# file to have it all embedded there. So snapshot testing is an excellent way to go about that. Now, a third thing that is sort of really important to me, typically when I'm using with sort of semi-structured data or string-based data, is leaning into semantic comparison instead of just doing like the classic string. Is this string equals to this string? So for that, we have a library called system text JSON, just JSON diff patch, and that allows us to actually do a semantic comparison of 2 JSON strings and ask it, are these 2 strings, are these 2 JSON strings equal from a JSON semantics perspective? So in JSON, you can move properties up and down in an object and change all of them, and it doesn't matter, the JSON object is still semantically the same. You can also remove some white space unless it's in the specific in the string, right? Then it's still going to be the same. White space isn't significant in JSON for the most parts. So we don't want our tests to break just because we change some white space or we change the orders for our properties. That is, that is sort of at odds with the 4 pillars we talked about before, right? That could also be small, subtle details like maybe you have a number value in a JSON property of 1, and that's equivalent to 1.000, right? So that is some small things that we would allow to be able to change in our system code without actually having our test break, because semantically it's still the same. So leaning into semantic comparison when we're working with JSON is going to make our test much more stable. Now, another thing we need a couple of tools to manage our out-of-process dependencies. So an out-of-process dependency is something like maybe a database that your API is using, or maybe Event Hub or email server, other things like that. And for basically having a consistent environment to run those in, we can leverage something called a library called test containers, which allows us to, again, in process, in our test scenario, spin up a Docker image configured with specific whatever dependencies we might be needing, and have that be spun down after the test is running. Another tool that is super useful, especially when you're working with relational databases, is Respawn. So Respawn is a library that allows us to reset the database after or before each run, rather, so that we can sort of have a consistent and deterministic and stable test environment. Now, this sort of brings up a sort of a question here. So what out-of-process dependencies should we actually bother including in our tests when we are doing testing? And so if you have a database, for example, if you have an API sitting on top of a SQL Server database, right? do I mock that database? Do I just stop it out during testing and not use it in my tests? Or do I, start it up and load all the things from there and sort of use it during my testing? And I think the rule of thumb for me is that database and something that is external visible to the outside world, or is it an implementation detail to that solution? So an implementation detail would be if it's just a database just used by that solution and it's not shared by maybe another solution that you don't own. Then it's an implementation detail, and in that case you probably want to include it in the test, if at all possible. It could also be a shared database that you share with another team. Well, then it would be much more reasonable to say, well, I'm not going to actually use the real database. I'm just going to use a fake or mock of it that I have created because I've created a fake or mock that represents the expectations I have of that database. And I can also use it directly in my test code. So it's part of the external observable behavior, right? If I have an email server, if I have an event hub or something I push data to whenever something happens in my system, that's also externally observable. So that's something I also want to include in my tests and sort of view and assert against and work with. But I might also be able to, might also be completely okay to mock them and stop them out and not actually run the real instance of them in testing. So the typical thing that happens if you mock out a SQL Server and you just, for example, use entity frameworks in-memory database is that you lose some of the things that are specific to relational databases, like commit scopes, right? Transactions that span across different tables, because when you're just using in-memory, well, as soon as you've written those bytes into that object you're updating, well, they are committed, but that's not how it works in the real world. So if it's possible at all, and you just have, for example, a database included in your test, if it really doesn't, if it doesn't detract too much from the value of your tests. Now, let's look at the demo solution. Let me just introduce you to what I'm going to show you a bit of data from. So the demo solution is sort of all the other end of the spectrum in terms of it's just an API and doesn't have any real business logic in it. It's a simple SQL Server on top of a CRUD API that allows us to create and remove and delete and update to-dos and query for them fairly simply. It's built on .NET 8 minimal API. It uses EF Core, code first. Fluent validation, so we can get some validation data or get some validation results on it. I'm using Swashbuckle as well to automatically generate this open API specification. Now, you could have gone, and there's definitely some advantages to doing sort of API first or contract first design of APIs, where you actually write out the API contract, the open API specification by hand, and then generate some server code on that instead of generating the contract from the server code. But this is sort of a quite normal scenario in .NET world, at least, so got to lean into that. And in the minimal API, where it's implemented using the type results, so that the types are represented in the generated spec file as well. And that talks to a SQL Server just running locally on machine using the local DB instance. So in this particular example, I'm not going to show test containers, but it's sort of a simple value add you can add on top if you have that scenario, if you need to. Now, so the JSON, the representation of the data we are sending back and forth, it looks like this. So a to-do has an ID generated by the server, and then it has a name. A description could also have been a good name for that property, and has a completed, and then whether or not when it was created and last modified. So this is sort of the simple demo solution we're looking into. Now, how are we going to go about testing this? Well, we're going to use the real database in our test, and that implies a few things. It implies that we run all our tests sequentially instead of running them sort of in parallel all at once. It also means that we will reset the database before each test. So it's important to actually do it before test and not after test, even though that might be the natural thing to jump to, because you might be debugging, for example, a test, and then you stop in the middle of it, and then the reset code doesn't get to run. Or you might have a test that crashes, and the reset code doesn't get to run. So it sort of gives the best results if you just do it before each test. Now, and we also get to just use a single API instance. So if you used Web Application Factory before, you can easily just spin one up per test, and then you can run all your tests in parallel, and you would just have a lot. But it typically takes, at least on my machine, takes a couple of 100 milliseconds to spin up a very simple API like this. So because we're just using a single database, we're running all our tests in sequence, we might as well just use a single API instance. And it actually turns out that with the resetting of database between each runs, and we just have to start up a single API and just spin up a single SQL server and migrate all our database changes to that one time, and then reset between each test. The test runs super fast. And you think about it, it's not really surprising because an API should be able to serve multiple clients really, really fast, right? So even though it sort of goes against like running everything in sequence instead of running everything in parallel like we usually do with in unit tests, it actually performs quite fast compared to what it would be if we had to spin up multiple databases, for example. Now, another thing we're also going to use is we're going to use the new time provider API that's part of .NET 8, but also has been backported to, well, all the way to Net Standard 2.0. And that allows us, and I have a sort of a manual time provider that you can use during testing. And that allows us to control the flow of time during testing so that our timestamps for the to-dos are super predictable. They're completely deterministic, so that allows our assertions to be, it doesn't matter if you're running on a slow CI server or a fast laptop or fast computer locally, it's going to be the same result anywhere. Now, to get all the things sort of hooked up together and working together, we need a few things. And in XUnit, we have, we're going to use XUnit, of course, we have this to-do API fixture, which is going to be the shared thing that is going to that is shared between all our test classes, tests, and it has the responsibility of spinning up the API using Alba one time, and it will provide access to the Alba host during testing, so that we can actually interact with that and do stuff with it. It gives us the ability to reset the database, and it also gives us access to the time provider that has been injected into the API instance, so that allows us to control time flow, forward time whenever we want to, and things like that. The next thing to make everything run sequentially in XUnit is that we need to define our own collection type. So typically in XUnit, all tests in a collection run sequentially, and the default collection, if you don't explicitly do anything there, is that a single test class is a collection. So all the tests in a single test class runs in a collection. But we want all our test classes to be in the same collection, so we define our own custom collection, and that references that has a reference to our to-do API fixture, so that to-do API fixture is going to be made available to all our test classes. Now, finally, to make it a bit easier to manage all of that, each individual test class in our solution will inherit from this to-do API test base type, which is annotated with the collection attribute, telling it that all test types that belongs to this should be sort of running in this collection. And obviously, it will have it has responsibility before each test to reset the database, and then also provide access to the to-do API fixture within each individual test. So now let me jump into Visual Studio to show you how things are working in there. So we can start with a snapshot. Well, let me actually do, can I? There we go. Is the font size large enough for you guys in the back? I get a few thumbs up, awesome. Okay, so the first thing we want to look at is the API contract side of things, right? We want to make sure that the generated API contract we get from Swagger actually looks and behaves the same. The problem is when you use Swatchbox to generate the API contract, it isn't part of your Git repository, so it doesn't show up in whenever you make changes to the API contract. So doing this actually gives us that. Now you can see we have a test class, and then you can see it inherits from our API test base that we defined before. And here we see what we can do here. So here we have we're using our host, which is available through our base type, which is the Alba host, and we say go and get as JSON the API contract, and just turn it into a JSON document. Now, because we're turning it into a JSON document, not a specific type, that means that we can pass that to verify here. Verify is the snapshot library we talked about before. And it allows us, through the extensions that is possible in verify, I've actually used the extension possibility in verify to enhance that. So instead of just using string comparison, it will use the other semantic comparison JSON library we had. So whenever we pass it some JSON document or JSON element or JSON node, it will use semantic comparison to verify whether the snapshot we have of our Swagger specification on disk is still the same as the one we have. So you can see, well, I can actually, let me just show it. So you can see this is the snapshot that was captured previously on a previous run. And here you can, I've collapsed some other things here, but basically you can see we have the OpenAPI specification document. And just to sort of show what the value is of the snapshot testing and combined with the semantic compare, if we, for example, tag move, why don't you want to move up? Oh, like this. So for example, now I've changed the document, and this, if it's just doing string comparison, this test would fail, right? Because we move things around. But semantically, the documents are still the same. So just to show you that I'm not cheating, we can actually go and run the test again. And it will spin up the API, it will go and query the thing, and it will still say, well, it's still the same. Now, if we actually go and change the thing, maybe we go and delete that one and run the test again. So what will happen is that verify will get the thing, and it will say, hey, these are not right. These are not the same anymore. And what it does then, it pops up sort of a diff window, and you can configure whichever merge tool you want to use. And it'll tell you, hey, this was there before, now it's not. Or rather, this on the right side is the verified thing that I manually edited, and this is the new thing we got from the server. These are not aligned, and then you can sort of assert them then and say, hey, this doesn't look right. Now, in this particular case, I'm just going to say cancel and undo my changes, so everything is back to normal. So that is sort of the value of snapshot testing. We have a huge JSON document that we want to keep around. We want to know that whether or not it's changed. This also adds to Git, because we're committing that verified snapshot file. So when you're doing code review and you see somebody has changed the snapshot file of the specification, you actually have the specification in your code now. So you have that knowledge, explicit knowledge that something changed in the specification. Now, let's see, let me find the right file here. I don't want to be in that one. Let's start here. So the next step, so now we sort of looked at what the API is promising. It's promising to return some data that looks in a specific way, but does it actually do that? Well, that's the next thing we want to look at, right? So here, let's create a test for the create endpoint that allows us to create new to-dos. So here in Alba, you are able to say, I'm going to create a new scenario, which is sort of encapsulation. And in a scenario, all the assertions you put in there are going to run, so you get a complete set of all the errors. So that is sort of some of the things that Albert does, so it makes it a bit more high level and easier to work with compared to the web application factory. But again, all of the things we're doing here, if you don't want to use Alba, you can do the same thing with web application factory, but then you just have to maybe build your own things on top of that to make it more maintainable. Anyway, so here we're just saying to Alba, send a post of raw JSON text with this content, and this is the type of content that our API is expecting to receive when it wants to create something. And the type you want to send along with that content type should be application JSON, and we want to send it to that URL. Now, the first thing we will do when we get a response back is we want to assert that the status code is 2-on-1 created, because that's what we actually expect to happen. We also want to assert that we have a location header that points to the to-do, and then with some ID that matches. Now, finally here, we're going to, again, with just using raw JSON, explicitly specify the JSON that we expect to get back. And this is an extension that I've created on top of Alba, some of the things that you can do there, and say, well, take this JSON string and convert that to JSON, semantically compare it to the raw JSON you received, and tell me if it's right, if it's still the same. So I can actually go and maybe move this up, and the test will still pass because, again, it's using semantic comparison. Now, obviously, there are some downsides with this approach, but it's very explicit. You're explicitly saying, I want exactly this JSON sans the white space that might be there otherwise. But it's quite tedious to find, and also we have to convert everything to the right JSON representation. So here you can see we're using time provider and calling get UTC now, and then you have to toString that using the right semantics, so we get a sort of a legal JSON representation of a timestamp, right? And it's not super nice to work with. It's not super maintainable. But it does have the advantage that you're being very explicit about what you expect the API to do, right? So let's look at another way to do that. So one thing we could do instead would be, so instead of specifying JSON strings directly in code, which is, even with raw string literals, kind of tedious, right? You could just use anonymous C# objects. So that's what we're doing here. So you can see that I'm basically just saying, here's some JSON, but it's just an anonymous C# object which has the same structure as the JSON we want to send there. Just turn that into JSON and send it along. And it sort of is less tedious. It gives us IntelliSense and gives us help with some other things. And also you can see down here, the same thing happens when we want to assert. We can just create an anonymous object. And in this case, because this is another extension method I created that basically takes the raw object, converts it to JSON, and then do the semantic comparison of the raw JSON received from the server, and then decides whether or not they're equal or not. And you can see here, it's a bit nicer when we do a time provider get UTC now. We don't have to explicitly convert that to a string because the JSON serializer in .NET will do that for us. But this is not super refactor friendly. So if you, for example, decide that all my tests where I'm creating new to-dos, then all of a sudden it requires a new parameter, or we change some data types. Well, I have to go into every single test and sort of update my anonymous objects because they're not known to each other, right? So a third option we might look at, let me find that, would be this one. So here, I'm explicitly referencing the API, the production code's DTO for receiving a new to-do. So I have a create to-do parameter, which is the thing that is declared over in the production side of things. And I'm referencing that, and I'm just giving it the name and this is complete. That will solve the refactor problem. And the same thing down here with our to-do DTO. We're doing the same thing. Now, there's a problem here, right? Because if the production code is refactored in a way that shouldn't really be breaking the clients, or rather it is refactored in a way that actually should be breaking the clients, because you might add a new property, or maybe add a default value in the create to-do parameter or in the output variable. Well, the test wouldn't break because we're using the same DTO both in the test project and the server project, right? So they are sort of tightly linked together. And that might not be what we want. It's fairly safe because we are also generating our OpenAPI spec. So supposedly, if the OpenAPI spec includes the refactor we did in our production code to the DTOs, then the snapshot test we did before of our OpenAPI spec would show up and say, hey, something changed, which you might not want to have changed. But it might not always do that. So this is fairly unsafe to do, to reuse the same DTOs both on the server and the client. So a better approach that I tend to lean into is just to recreate the DTOs in the client side. It's a little bit of extra work up front, but then you have a loose coupling between the two projects. You're being explicit about what are the types of types I expect to be flowing back and forth, and I still get to stay in C# and strongly typed. I don't have to spell out explicitly the JSON I want. So that is definitely what I suggest to do. And then you also have the refactorability. You just refactor your local test-based DTOs, and then supposedly it's going to be easier to discover which test you need to fix. Now, that was sort of the creation step. Now, actually, there's one more thing. Obviously, this is a small DTOs we are flowing back and forth. They can easily have them inline. But what if you have larger data sets that are coming back from the server? Well, you could leverage snapshot testing again. So in this particular case, we are just creating a scenario where we are posting some data to the endpoint and verifying that we get the right. That's something you have to do with Albert saying, well, the response should be a 2 or 1. But then we're using verify, where we're just passing in the scenario result we get from the server. And that will actually create a snapshot that will capture the headers, the query we did, and the response we got back as a snapshot. So that could be very useful if you have a large payload that comes back to you, right? So you can see here, it will create a snapshot file that looks a bit like this. So you have the request, what was requested, was a post, and the status we got back, the headers we saw, and all of that. And sort of that is a good way to make sure you capture everything about the request if you need to. Okay, how am I on time? I have 5 minutes left, that should be okay. Okay, now, let's change gears slightly. So, we talked a little bit about before what is implementation detail, what belongs in the test, what does not. So here we have a test where we want to test the get by ID functionality, right? And to be able to get something from the ID, because we're starting with a blank database, well, we have to create something in the database first that we can then get and check that when we ask for a thing, we get the right thing, right? So in this particular case, in the arrange step, we go into the services collection that actually exists in the server API, in the API that we're running. We can go and access that and say, hey, give me that to-do DB context from there. And once I have that, I can go and new up a to-do. And this is actually the data or database object that is getting stored in the database. So this is not the DTO, this is the domain object that is getting stored in the database. We new one of those up, we add it to the database, and then we save our changes. And once that's done, we have to-do in our database we can go and query for. And then in our X step, we will go and query the to-dos by the ID. And here we can actually use the should be equivalent to, so we get a test to-do out, but we have our original to-do, and we can just say these two should be equal. Now, if the database is an external visible thing, this might be completely okay, and it might even be something you have to do, right? Maybe you don't. Maybe your API doesn't have a create method, so you can't actually create it through the API, right? So maybe you actually have to poke into the database. So, but ideally we don't do that. Ideally we don't have this level of integration of this level of dependency in our test code on implementation details of our production code, right? That's really important because that's going to hurt our ability to protect against refactorings in the production code. That shouldn't affect our test. So a better solution, if possible, is always to leverage on the public surface we have of the thing we're testing, in this case the API. So we just use that to create a to-do through that. And here I have, I'm following the object mother pattern, so I have a helper method called create to-do that I can reuse across my tests, so I don't have to repeat that. But basically it's a method that will just post to the API and assert that went well and return the test to-do out again. And here then we can sort of use a scenario again and get the to-do and verify that the JSON we received is equivalent to what our test to-do that we created. So again, we are leveraging the internal test DTO types. Another thing we can quickly look at would be like how do we deal with edge cases, scenarios, things like that. And again, it's quite straightforward in Alba. You create a scenario. Here we're trying to query for DTO that doesn't exist. And yeah, we should have a not found. And here we can actually, so here I'm actually leveraging the problem details type which comes with ASP.NET Core. So that's okay, because that is part of the framework. So it's not going to change under me. That's not going to be a refactoring I can do in my production code that will change how the problems detail thing sort of works. So here's that sort of a slight change in approaches where it's okay to actually leverage things that is server-side specific, right? To say, well, I expect that our content should be a problem detail that has these properties, and you can sort of assert on that. Now, let me double check my time. 3 minutes left. I don't want to keep you from your drinks and your keynote speaker here at the end. So, I want to show you one last thing, and going back a bit to the whole time provider and controlling the flow of time. So this scenario is we have a to-do that we want to update. So let me zoom in on a few interesting points here. So first, we use our object model, the create to-do, to create a new to-do in the database. But then, so you have to remember, when you're using time provider, and because we have the manual time provider injected into our server-side things as well, the manual time provider, time doesn't move, time stands still unless you explicitly tell it to move time forward. So that's what we're doing here on the next line. We're telling time provider to advance time by 1 minute. So that means that we can now go and test this scenario where we well, obviously we go and use the put and put some new updated parameters. In particular, we say that now this task is completed, and we get the right content type back. We can assert that it's for 204 no content, because we don't expect to get any content back when we're doing updates. We can even be explicit and say, hey, that shouldn't really be any content, right? And so in this scenario here, we also we are sort of testing both business logic and API servers. So we have an extra assert step down here where we're saying, well, okay, after I've done this, I actually expect to, if I go back to my go back to my API and call it again and say, give me that GTO, test, to do, I just updated, I should get one back. And at that point, I can sort of do an equivalence test and say, hey, well, is the to-do I originally had up here, if I use the with statement to basically update that and say, I want to have the same to do, but this time I want it to be with a completed status, and I want the modified time to be updated based on time provider and get UTC now. So I hear people are clapping all around me, so I think that's my cue to get off the stage as well. Let me quickly jump back in here and give you the summarizing slide. And we need to go all the way to the very end. Oh, that was too far. It's stressful when you hear people clapping around you. Okay, so that's all I had time for. Here are some links you can photograph with links to the various libraries. There's also a link to the GitHub demo solution where you can look into all the small extensions we've built for this demo purpose. So you're able to replicate what I did back at home. It's been excellent talking to you. Thank you for hanging out, and I hope you have a good rest of the conference and party tonight.